How about now? There it is. I don't know what happened. Yep. Nope, it's me. I'm sorry. Well, and it's a weird thing. Like right before the stream, I was just double checking all the settings, and I guess it was working, and I checked the settings just to make sure, and then I came back, and then it wasn't working. But I had already launched the stream by the time I noticed it. Anyway, I was getting really mushy there for a second about just appreciating the ability to come in and do this. How much I enjoy doing these streams and coming to get to hang out like this. It's just so much fun for me. I really love this. And as I was saying, that was a huge part about what I love with my like hands-on class that I'm doing now, where we get to come together for a full week and just spend that week just diving through all kinds of just fun stuff. At least if it's fun, if you love this industry, like if you genuinely enjoy what you do, this excites you, like it. Anyway, I'm not trying to get promotional with my class. I'm just trying to express I appreciate the ability that y'all give me to be able to do this, to come sit here and pontificate, as I have. It's just a fun word. Anyway, just get to do this, right? And really live this out. Like it's just crazy that I wake up to do this every day. Like it's a lot of work, but it's worth it. Like anyway, thank you. I really appreciate it. Like just thank you for being here. Thank you for being so supportive. Thank you for all those that have really been behind me for so long. It's just been incredible. So anyway, let's dive into today's stream. I'm still working on trying to. So here's a goal that we have. Now this doesn't mean don't post your questions. By all means, we're here to do a Q&A session. That's what this is a live Q&A. I don't really care what you have as long as it's mostly industry related. So feel free to throw everything into the comments. Whatever questions you have, I'll get to them as soon as I can. I have an idea on trying to do some fun things, but I want to catch up on all the history questions I have because I still got a bit of a list of things that have been stacking up, and I haven't been able to get all of them answered yet. So we're going to be working on that some more. But like I said, feel free, please. This is an open Q&A. I've had people come on and just ask, what is saturation? That's okay. Like we can discuss that here. That is just as important to chillers as it is anything else. All right. I don't want the mindset that we have to ask these super in-depth technical questions to set in too hard. Like it's just not true. If you have what seems like a very basic or overly basic question, well, it's better that we go ahead and answer it. And guess what? You can ask that question here and not receive any judgment and not get made fun of back at the shop and having to ask somebody else or a senior. Like you can avoid that whole thing by just asking it here. All right. To be clear, that's kind of the point of this. I know how that is. I've been there. Sometimes it's just like, man, I'm trying to figure this out, but I can't make sense of it on my own. But I definitely don't want to ask because that's not going to end well for me. Like I've been there. So this stream is intentionally built to be a place so that you can be ignorant for a minute and just ask what seems like a dumb question in your brain. Anyway, I'll get off my soapbox there. Let's move on to the first question. What's the best brand? Sadly, I don't have a overly direct answer to this question, but we can talk about it. And let's start with just describing, okay, what are some of the major brands in the industry right now? So in no particular order here, okay, I'm not creating a hierarchy. We have York, we have Train, Carrier, Daikin. We have Dunham Bush, Dunham. We call them DB for short. I'm just going to say Dunham B. I know there's okay. So then from here, we start getting into kind of the more technical niche ones. So we start getting off into the VRF chillers. Okay, so this could be Samsung, this could be Daikin. Like, they've all got their own version of this. And then we start getting into little process units, which are a million brands under the sun. Okay, sorry. So without getting way off into the antics here, in today's industry, the 5 main players we're going to deal with are going to be from Dun & Bush to York. Okay, so that being said, let's just remove this extra piece off the board here. And Dun & Bush, so keep in mind, Dun & Bush, oh, by the way, I don't have McQuay on here. McQuay is considered under Daikin, okay? So there are still a lot of McQuay machines out on the market. Like, there's still a ton of them, and there's going to be certain folks that work on that heavily. Daikin owns McQuay, so when I say Daikin, it is in lieu of just separating the two. They are one combined brand at this point. That's why if I talk about Train and Arctic Cool, okay, I'm not going to talk about those separately. They're one combined brand. If you get into, what is it, Quantech, I think they call it, that is York, right? Quantech or York's offshoot brand that they have. Okay, so we could get into, I think it's worth considering a multi-stack. I did not include them on this list. So multi-stack. I feel like they spell stack weird, but it doesn't matter. So multi-stack, they also have a line called Air Stack, which is a line of their air. I think it's their air-cooled line is Air Stack, and then you have multi-stack, which is their water-cooled lines. Is also where you get into their modular systems. And again, each of these have their own versions of this stuff. Multi-stack's just one of them on the market. And I'm not going to list Danfoss here because, well, Danfoss just makes a compressor. Okay, so I'm just trying to get a lot of the nuances out of the way so, as we kind of go into this conversation. Okay. Each of these has their own strengths, weaknesses, and place. Okay, they do spell it weird. That's, yeah. S-T-A-K. In my head, I was thinking they've got a different spelling. It's not the, anyway. Thank you. Each of these have their own strength. To be frank, there's not genuinely just one brand that utterly dominates the others. So here's the thing. I want to admit, I don't have a strong love for Carrier. I don't care for their control systems. I don't care for their overall design. Like, there's just a lot of things with Carrier, specifically their water cooleds. And even so, Carrier is actually quite competitive on their air-cooled screws. Okay, before I get too far ahead of myself. Their water-cooled centrifugals, specifically, compared to what else is on the market, not a huge fan. I think they really struggle. But I do think Carrier is very competitive with their air-cooled screws. They're not only very competitive in pricing, they've got some pretty decent warranty options. I think they do well. I have seen some, call it manufacturing quality control issues. Like, I have seen that with Carrier, but to be frank, I've seen that with the others too. Like, they're going to have some slip-ups. I've just had more of those slip-ups, or I've seen more of them with Carrier than I have the others as a whole, but they're still going to happen, okay? There's no way to 100% quality control everything. So, yeah. I do think, and yeah, I mean, the Carrier's float valve, like, it works. Once you understand what it is, what it's doing, I get it. It's fine. Do I prefer it over some of the other valves? Not really, but I get, like, it does work, and it's also a valve that can scale very, very well, which is not something that's true for many of the others. Now, and another credit I want to give Carrier here. Carrier is still actually doing a fairly decent job having literature out there. Now, they've gotten more and more restrictive on this, and we see with their newer lines that they're providing less information. If you go compare older machines manuals to today's, They are different, but they're not as dramatic as some of the others have been. People like York and Train is a much bigger difference in how much they've removed from their manuals and how much harder it is to get some of those manuals at times. Okay, so I think Carrier is the most competitive with their screw, and even scroll, their air-cooled series. With what Carrier has done with their air-cooled, and even though we have to use the app to get a code and stuff now, like, okay, at least you can still get the code. You can still get into the service modes. You can still do a lot of things with these Carrier units, specifically the air-cooleds, that I appreciate, right? I just genuinely appreciate Carrier from that perspective. And that is not something I can say with York. Now, York and Train massively dominate in terms of centrifugal machines. They also have a huge air-cooled presence. Like, they've got very solid machines. Like, there's a reason they've become so strong in just about every market. I mean, the two of them have done an extremely good job, especially at larger tonnages. And I think that's where they've really kind of shown in their market. And that's where, when it gets into the really big tonnages, York and Train are just what you see a lot of the time. It's just what you see. Now, Daikin has their own versions of things. Dunham Bush and Multistack just don't really even compete in that side of the market. They're on the smaller side. The issue, some big gripes I'm going to make with Train and York both is their control systems. Their control packages are great themselves. The issue I have with is their restrictiveness, them closing down on how much access they're allowing third party to have. I do not like it. Don't like it at all. And York, I'm seeing some cracks and seams with York and their ability to use Access Manager and the ability for the customer to pressure to get factory access granted to them. I do see some cracks beginning to form where this is not as hard as it once was. Okay, they've gotten a lot of pushback, a lot of pressure for what they've done with their what they've done to lock down the OptiView panel. Now, I mean, to your point, JCI is not easy to deal with. To be frank, neither is Train. Just saying. They're just. My issue here is they feel like they get further and further from being third-party friendly. They're getting more and more competitive with third-party in the field from a service perspective, and they're not only are they trying to sell the equipment, they also want to do all the service to the equipment. And I mean, it's fine, it's competition. I guess I get it. It's just frustrating and annoying because at one time we had a balance, and it felt like they spent far more time trying to improve their machines and sell them than trying to necessarily take all the service. And as factory service, they get a ton of work anyway through startups and commissionings and warranty stuff. Like, from our perspective, being third party, you got plenty of work as it is. But then they've been taking it a step further in recent years. Now they're trying to take all the maintenance contracts. They're trying to take all the service work and do all the regular stuff that third party has thrived in for years. And that I just don't appreciate. And I don't think it's for the customer's benefit. I think the customer having more and better options. But their control panels kind of play into that. I'm kind of getting off on a tangent here. Anyway, I am seeing Access Manager is becoming less of a headache. It's still a problem, but less of a headache than it once was. Now, Train with their TU software is still just ridiculous. The fact that they went from TechView, which was to this day still free, still open, you can still get it, to then they went to TU, and you just completely locked that shit down. I really dislike that. But they make great machines, okay? So they have, I will say, their more recent RT, AF and AE, even though the AE I think got discontinued, the more recent air-cooled screws they've had have had a lot of issues. Granted, Trane made some big changes with those, and they're obviously still going to be working through that. But I would say their air-cooled scrolls are still very strong, and their centrifugal lines are like the cream of what I would consider for Trane. Okay, and again, these are all just my personal opinions, and I'm just doing a bunch of ranting here. I will move on from this here in a minute, but getting back to the core question that kind of got us started on this is, what is the best brand, right? The high level, just short synopsis. There's not just one best brand. There's not one brand to fit it all. There's not one brand for anything. They've all got a lot of pluses and minuses. They're all trying to do things. Some of it we agree with, some of it we don't, right? So I'm just kind of giving a high level overview of my different thoughts with things. The Trane offices are not much better. Yeah, Trane is not any better than JCI in my opinion. They're not any more helpful. If not anything, I've gotten less assistance from Trane than I have JCI. Just saying. Granted, that's going to be regional specific. So in my region, that's been the case. I've tried to collaborate with local Trane multiple times. Literally just won't even get them to talk to you. That's not necessarily as true with JCI. I have actually gotten some kind of back and forth with JCI at times. So yeah, the Symbio are by far the most third-party friendly machines yet. You don't need TU with Symbio 800. Well, but you do still need TU for certain things. Like if you're doing any kind of altercations to the commissioning, and it's only if the binding view is enabled. There's the ability, and it depends on the software version, where the binding view can get turned off. And I've seen that happen, where they go in and turn it off so that the third party can't come in and do it without the software. You can't even turn it back on without the software, to my knowledge. So unless I'm just mistaken on the TU and Symbio system, and feel free, like if I'm wrong on some of these things, I would like to know, and I would love to have an email. That's not right. I'd love to have an email explaining to me why I'm wrong about certain stuff. Okay, I don't stand here or sit here to intentionally spread or give incorrect assessments. Okay, so HVAC time at hvactimetx.com. Okay, if you can send me an email, like if you have some information that I'm just wrong with, please share it. I would much rather be as accurate as possible, and if I have a incorrect opinion on something like TU, again, so that's the adaptive view. Yeah, it's the UC800 system. All right. No, I'm tracking with you there. You said not anymore. Okay, so do you mind when you say not anymore, as in the newer software versions don't have the ability to turn off? Next time in front of one, I'll send you some stuff on. Yeah, that'd be great. No, I'd love that. Yeah, whether LinkedIn, Instagram, or email, either way, because my most recent understanding is like those things are able to be changed in the configuration. So that would be a huge change for Trane, one that I would heavily support. If Trane moved to this most recent software package or version, firmware version, whatever you want to call it, where the UC800 series, which is what we've been connecting TU to, was highly configurable and serviceable from the panel. I know that, again, if it was enabled and if you had the newer version of the software, you could do binding straight from the panel. Okay, so different control platforms. The UC800, which is Reliatel, you may need it. Right. Symbio. Okay, so hang on. All right. So the UC800, right. So the UC800 is what they're putting in their centrifugals. It's not what they're, I think I've seen them use it on some of their newer air-cooled. The Symbio 800 controls binding view with the display as well as server. Yes, and So the Symbio is what I've seen in some of the air-cooled lines, but I've not seen the Symbio in. This is a great discussion, by the way. I really appreciate it. I've not seen the Symbio in the centrifugal lines. I've seen the UC800 series, which requires the TU. But I have seen that, so not anymore. So are the UC800s, or are the centrifugal lines, the CTV series, is that getting the Symbios now, where all, like, everything's built in? So does that mean they're moving away from TU long term? And see, this is part of why we need to have these discussions, and people who are in the know can kind of share, because then we can actually let more people know. And if sometimes these are simple upgrades we can do in a panel, we can go in and explain these things to the customer, and have, like, sell that upgrade to them. Reliatel is dead. Thank effing God. Okay. All right. No, this is great news. Please share. I want to hear more. Like, you've got my attention, sir. Absolutely. So it sounds like, without getting harsh about it, did Train, I mean, granted, maybe it wasn't working out with the Reliatel, but I know that Train took a huge amount of heat with the whole UC control package and having to use TU. I'm part of the heat that got applied. So TU is still relevant, but third party is very limited. Okay. You know, end of the day, here's the thing. Being able to bind sensors and do some basic service tasks, like some overrides, some manual controls, which you could already do some of that with the current UC system with Reliatel. So you could do some of that. Yeah, so the customers complained, and they changed it. Mess it up, it's on you. Yeah, well, that's so that was the argument. That was the argument that both Train and York have tried to stand on, is, oh, well, everybody keeps screwing the machine up, and so, granted, they claim they were taking heat for having bad, like, they were getting the heat for the machines messing up, when in reality it was third party or the customer themselves making the mistakes. But I think there's some truth to that. Don't get me wrong. I'm not trying to say that there's not any truth to it, but I don't feel like that's as true. Like, that's not the whole story. I feel like there's way more to that story with their decision to go that path. And now they've gotten so much flack, so much pushback. Just everybody's that's not them has been upset about it. That now we're seeing that, like I said, there's been cracks with OptiView with their access manager, and they're making it a little more easier to get that access. And heck, I can't tell you how many Daikin and Dunham Bush machines I've seen sold, and even multi-stack for that matter, how many of these I've seen sold because they're not doing that. Like, there's a ton of machines that I've consulted with, been a part of selling the job, that they flat out said no to these and went with these strictly because of the controls package. It has happened a ton. So, I don't know. I think it backfired. But, which I guess that's part of what we're saying. I'm not trying to be harsh. I'm not trying to be rude. This is great news, everybody. So does that mean, here's a follow-up question. Does that mean that we could do we could do an upgrade from, like, does Train offer an upgrade package, even if you have to purchase it, that's fine, where we could go from the UC800 to a Symbio 800 control package? Is that right? Take multi-stacks with the bearing, the clearance you can get with the MTT tool, whatever it's called. Yeah. TU, you need some software from the bearing. Okay. Yeah, to be frank, to be clear, I don't like multi-stacks control panel. Out of everybody, multi-stack's the one that I find the most infuriating. The one that I like the most, I like Dunham Bush's the most. Okay, so if we're just talking control panels here real fast, Dunham Bush, but they're using MCS, and they're not even using a proprietary version of MCS. They're just using out of the box MCS. Now they do have like pre-programmed software loaded into that MCS, which is built on MCS's core. But all the great things that make MCS what it is still there with the Dunham Bush panel. And I personally am a huge fan of what MCS has done. That's micro control systems. So, like in terms of just direct comparison, my Dunham Bush doesn't have, like, they make really good machines. I like Dunham Bush, but they don't have the same presence, nor do they really seem like they're trying to have the same presence as the rest of these, right? And I think that's okay. Dunham Bush has been far more focused on more larger industrial manufacturing, data center type of clients. And that's where I really see them trying to push. That's what they're trying to get into. And I'd say all more power to them. They're doing it successfully. I know of multiple pretty good sized data centers that have gone in with Dunham Bush machines on their air cooled scroll systems, or not screw, sorry, air cooled screw systems. So yeah, I do really like Dunham Bush. Now, are they to a point where they beat any of these other four, the four primaries? No, I don't think so. Other than their control package, like, what makes them so unique is the fact that they use MCS. Like that is just, they have a solid chiller. They have a very good support system. Like, they do good on everything else, and they have the MCS controls. Like, that is their key, just gotcha, in my opinion. Daikin has a pretty decent control system. I really like their new HMI with the touchscreen and the graphics. It's really, really cool. It's very helpful. It's very useful. Like, I think Daikin does a pretty good job overall. You know, I think there are some weird little quirks you run into sometimes. I think they have gotten a little bit more restrictive on information than I'd like them to be. Okay, I really wish Daikin would be more transparent with some of their manuals and information than what we have seen them do. But that would be, I think Daikin overall, I'm a huge fan of Daikin as a brand. And I do have to say, I love the York machines. Okay, what York has built with their YK series, even their YMC squareds, still getting my opinion put together on the YZs. But York overall, while they're far more complex, that's the beauty to trains. Okay, train equipment is so simple in its design, and not in a negative way. Okay, train equipment is just, they really capture the beauty of simple engineering, which takes a lot of really complex engineering to do. Like, that's the thing I don't think people appreciate, is to create something minimal and simple from an engineering perspective takes a lot of extra work, and it is much easier to just make something more complicated and complex to do the same thing. That's my experience and opinion with just the engineering side of things. And I think Train is just, they do an amazing job of just capturing that simplicity. Like, they've done, anyway. So mechanically, they're very simple, easy machines to follow. That's not necessarily true with York. York is far more complex, far more convoluted, but I don't know. Something speaks to me about the York machines that more than the others do overall. I just hate the rest of it. I don't enjoy working with JCI. I don't know anybody that does. And I don't like what they've done with OptiView. I think it's changing. I think we've seen some shifts on that. What you're describing, if Train if Train is truly backed off on that what they've done with the controls, that's going to put so much freaking pressure on York to back off with what they've done with OptiView. So much freaking pressure, because part of what enabled these two doing what they did together, and Carrier to a degree, like these because they all did it simultaneously, it made what they were doing technically possible, because they are the major players in the field. And the fact that they're starting to back off on that, like it, anyway, I'm going to keep hitting that same nail on the head. See. Oh yeah, as far as you know, there's no upgrade from Reliatel. Okay. Well, no codes either. Here's you RTWD. Yeah, okay. Fair. Fair. Yeah, the gas pump system. Uh, yeah, the gas pump system is. Yeah, why not just go with an deductor? I don't know. That is 100% agree with your point. The gas pump is a bit ridiculous. Just was I don't know what's so hard about the an inductor. Like really, every freaking other machine on the market just uses an inductor to do exactly what they're doing. So why not use an inductor for themselves? Yeah, it's almost like to uh York using their own terms for absolutely everything. Is we have a PRV. You mean you have an IGV? No, it's a PRV. Okay. We have a VSD. Oh, you mean VFD? No, VSD. Okay. Thank you. Got it. Oh yeah. They said it was energy. What, they're saying the gas pump is energy efficient compared to an inductor? Why? Because it spends less time. What? Maybe it uses less total discharge gas to coming back into the compressor for the oil recovery. Like that'd be the only way I could see that argument making sense. I do see new to Chiller World and about to take a job at Daikin. How do you feel overall about their equipment? Yeah. So Daikin, I love Daikin. Daikin actually has, yes, less amps. Okay. Yeah. Okay. I mean, I'll come back to the Daikin question in a second. That sounds like some marketing, if you ask me. Just saying. Like that is flat out just some marketing. Yeah. So they're using less amps because they spend less time by basically because that's what an inductor does to a degree. It's a hot gas bypass, kind of, not literally so literal. Okay, don't. I'm not saying it's what it is, but its basic effect in the system is a hot gas bypass. We're taking some discharge gas, we're putting it through an inductor system, and it draws it off and puts it back to the compressor. Train's gas pump spends less time bypassing in total because it has a cycle timer that it stops, fills the little container up, then shoots it back up to the compressor, then stops and fills the little container up and shoots it back up to the compressor. Anyway, yeah, that's hilarious. Okay, so Daikin. First of all, congratulations on the job. That's really fun. It's cool. Daikin, I've heard. So Daikin North America, across the board, everybody I've talked to has just so much positive to say about their experience working for them. I've worked with Daikin, not for Daikin, but with Daikin for a lot of years, and I've found them very, very easy to work with as a manufacturer, right? Not perfect, but I really enjoyed my time with not only the equipment, but also with them as an OEM. I think Daikin definitely has their own way of thinking about things. They're bringing a lot of that McQuay mindset into it. Like you can feel so much of that McQuay influence on the machines they're making. And I'll say Daikin was one of the major ones leaning into the mag bearing systems way before it became as popular as it is today. Um, and I don't just mean adopting the Danfoss turbo core. Okay, everybody kind of did that as a just get in the door kind of thing. But Daikin was one that actually started working with Danfoss pretty early and then developed their own lines of mag bearings based off of that, right? And like that's what the WME is, okay? The WME was Daikin's, and they've had that machine for a long freaking time. I mean, that was one of the first. So now, granted, this was a very early version. This was a what I think a vintage A, if I'm not mistaken. But Daikin, the WME was one of the first sets of centrifugals I learned on, that I cut my teeth on with centrifugals. I had CVHEs and I had Daikin, or the WME. Like, those were the two machines that I spent all of my time on in the beginning, and then I got into Yorks and other stuff in addition to that. And so, or later on, my first year working centrifugals, that's all I saw was a set of WMEs and some CVHEs. And that's what I cut my teeth on with centrifugal stuff. So like Daikin has been one of the ones that have just leaned so hard into, okay, what is the next advancements? Where are we going with this? What can we do in the industry? Like, I think it's been so fun to watch Daikin and really push things, and then everybody else see what Daikin did basically and try to start catching up to it. What Train has the RHWD, I believe, is their competitor to the smaller in-house made mag bearing line that they have. And the YMC squared was York. Now York did it first, I think, and then Train has come in and with their RT or RHWD, I'm pretty sure that's the right model, is also there. It's a dual drive mag bearing. This is coming off of York's high speed single drive. Anyway, huge fan of Daikin is my high level summary. I think you went well. Yeah, HDWA. Oh, HDWA, that's what it is. Agility, that's right. Thank you. But no one ever maintains PSID, and they pay for yes. Yeah, because they just try to. So it's two things. One, they either try to push the condenser water too far. To your point, they don't maintain differential or compression ratio across the compressor, so then you don't have the same oil return that you need, or they don't isolate the evaporator properly and they let everything migrate. Like, yeah, I mean, it's just every freaking time. Where you find service guide for chillers? Okay, let's talk about this. Okay, let's roll into that question. I've ranted enough on this. You all get the point. There's not one. Okay, high level. That's it. There's not one. They've all got their positives. There's so many variables. It's just not that simple of an equation. Okay, so. Yeah. Now, let's talk about this real quick. All right. Where you find service guide for chillers. Other than just knowing somebody, there's a few options. The first step is use the model number to your benefit. Okay. Now, it depends on the manufacturer you're going to be looking for, but many of them, it'll be the first 4 digits of the model number in the tag, not the serial, the model number. And we want the unit model number specifically. So in some of these, the drive panel will have its own model, the compressor will have its own model, And then you may see numbers for like the evaporator codes and the condenser codes, things like that. We don't need any of those. We need the master model for the entire chiller. That's what we're looking for. That'll get you where you're trying to go. All right, so let's use we'll use a CTV series by Trane. So with that, we're talking so let's say a CVH. It could be F, it could be an E, that could be a G, that could be an H, CVHH, CVHE, yada, yada, yada. All right. So if you do this and then go to, let's see, just add IOM. This is in terms of just a very, very basic entry level search. This is where you can begin. And let's look at this. Okay. It's over here. Hang on. All right, I'm back. So let me pull this up real quick and let's actually just kind of talk through this process. So what I'm going to do is I'm going to pull up an incognito tab. That way, like if you were just starting from scratch, I look up manuals and stuff all the time, but I want to use an incognito because I don't want it to be influenced by any of that. Like, so what does this look like? So we'll have a CVHF IOM right there. Okay. Now, your part of the question was service guides. I'm going to tell you, getting the actual service, like tear down information and really, really in depth, like how to repair X, Y, Z. Extremely difficult to get those. You're almost always going to have to either work for the OEM or know somebody who is comfortable sharing. By the way, they get fired if they get caught, so it's not a small ask for them. Don't think that it is. And yeah, that's really about it. Those are your primary options, and those are valuable gold in the industry. But if you're looking for just basic information, that will get you a long way. So we can see right here, just CVH IOM, it pulls up. This is a PDF link to the CVHE, F, and G. Now, there's a step deeper you can take with this. So we can see that, so this is the IOM for it. This has a ton of good information to begin with. If you're just looking for something to start explaining the machine to you and get you started, this is a great place to begin. Now, if we take this a step further, we see that we have a code down here, CVHE-SVX. Now, there's an O2P. The EN is referencing here. Zoom this in. The EN is referencing English, but this is the actual manual code. Okay, and this is for this one released in October of 2019. We can take this further and say let's copy. As I struggle with technology, let's just copy up to right there. Okay, so CVX, and let's go back. No, it's not what I asked for. Okay, and let's paste that in. Now, the point of doing that is, okay, we may be able to start getting other manuals to pull up that we're interested in, more than just the that specific manual, because basically, now I'm not going to actually go through all this. The point is, like, these numbers are the actual manual, say, model indication. And okay, so you're saying, okay, let's try that. So leave out the P and take the O2. 0, 2. What happens there? Yeah. So the point is, we can dig into all kinds of others. See, now we get the purge system manual to pop up, right? So some of these are just really good manuals that if you don't know how to search it, you may not know how to get this information to pull up. And so now we see we have this CVXOO to B, which is referencing their purge system, which this is specifically with the 514A. So this is their newer generation, if you want to call it that, of their purge. Okay, so this is one way to do it. And if you start with what we did the first time, back up a little bit here. So if you start with what we did the first time, and then you can start finding some of the manuals and then figure out, okay, what is the manual code for that series of manuals? Now we can dive in further. We can do the same thing for a York, okay? So Yorks are different. They're not using a 4 code. So different ones, Yorks, okay, York water cooled. A York air cooled, so let's say a YCIV, okay, that would be another one, YCIV IOM, look that up. Now, you're going to find that York, and we're going to do a YK as an example here. But either way with these have a different way of displaying the manuals. So let's go clear that. Let's go with, go back in here. YK IOM. IOM, by the way, stands for Install Operations and Maintenance Manual. So we have an H series service manual. Just click on one and see what comes up. Okay. So what this does, this actually is a perfect point or time to make a point here. Do you see this 160 dot some numbers dot information? Okay, this is actually a master list of different manuals you'll need for the mod H or the version H of the YK. And if we want to search these now, I can break this down what this means. So the 160.00-M whatever, these are specifically referencing your drive manuals. So there's going to be your VSDs, your starter drives, things of that nature. When you get into these others, so a 160.49, the 49 is the, it's not G. Let's see, because 75 is H. 75 and 76 both, I believe, are the H series manuals. The difference is the 75, I think, is with the 9 point whatever OptiView version, and the 160.76 is the H, still the H version, but it's, I think, the newer 10 point whatever, which is where they introduced Access Manager, is with the 10.0 softwares or somewhere in that vicinity. Anyway, the difference in there is the model of the software package, if memory serves. The 140 or the 49 is, I'm pretty sure that's the G series. Basically, it's an earlier revision. Okay, that's what we're looking at. And this is going to be true for any of these machines. So if we wanted to look at, I need to explain. The M. M is your, what do they refer to it as? It's not maintenance, it's your service. Your M's are your actual service manual, and you can see that here with their description. With the O's, these are your operational. So we see the 160.00-0 whatever. Okay, so these are going to be drive manuals here for the drive package, whether it be the variable speed, whether it be just the solid state. Then we get into the 160.76.01. So you have your 01 and 02 manuals. Those are going to be your IOMs. Okay, so your 01, your 02 are your IOMs for that particular machine. So we can pull that up. Now I'm doing this through JCI's actual database, which I'm blanking on the name that they call it. Man, somebody help me out here. The name that the database you can go to for JCI to search manuals for. Anyway, even if you didn't use this database, because I'm blanking on, they have a specific name for it. What we're looking for is we can take this number. So if you search YKIOM, that's what got us this far, just searching that. Then if we take this number here, Ooh. Kind of freaked out for a second there. If we take this number here, and we know that, okay, we want to find everything we can find for a YK, which is model 160.76. All right. Let's come back over here. So we know that we know that the YK is a 160.76. That is their indicator within JCI. That's their most recent for the YK. So now we start having various manuals pull up. We have the CL1. So if you're just looking for ways of just finding manuals, we can see there's our 01 here within that scribe system. We can start looking through and finding the various manual, right? Yeah, we can get the engineering guides, which show you a lot of the like design data parameters, stuff like that within for the YK. They can be quite useful. Anyway, this is how you could dive deeper if you're looking for more. Now, if we just specifically are interested in, okay, let's see if we can find on the open web just a YK M1. Can we find the M1 manual? Let's see. CL2. That's an engineering. So we know it's engineering because it says EG1. All right. So that's the form. This manual's bib. That's operations or lib or whatever. I don't know what to call that. Anyway, you could continue this process to keep it going. And get the you can find the manual that you're trying to seek. Now again, there's a lot of them that are not going to be accessible to you. A lot of those M series manuals that are service manuals, you're going to have a hard time getting your hands on those. Now the 01 and even the 02, which are your operations manuals, those shouldn't be too bad. A lot of the drive manuals are going to be difficult to get your hands on. It just kind of depends. But in terms of how do you get them, which was the core original question, like these are the processes you can go through. If you have nothing else to start with, if you could just pull the first bit of the model number and then search that. So you have your YK series, but so we have YK and YZ, but then York also has YMC squared or YMZ2. Okay, it would be a way to represent that. You have the RTAA, RTAC. With Daikin, we have 3 letters. It's the AGZ, AWS, AWZ, I think. So yeah, with some of Daikin's, you're looking at the first 3 letters are your model. Your WMC or McQuay, your WSC. A water-cooled simplex centrifugal is WSC. It's what that stands for. WDC, water-cooled duplex centrifugal. Then you have your HDC or HSC, which are your heat recovery centrifugals by McQuay. And then, anyway, if you can figure out what the model is, search for IOM. Then once you do start finding IOMs, take the code for the IOM, and you can start experimenting with, okay, how much of this code can I use and how much of it can I use to find other manuals, other material, other things to try to get the information I'm looking for. And again, all of that just kind of takes you, it takes a lot of time. It's a rabbit trail you have to dive into. But if you can follow that thread deep enough, you can start to really find a lot of extremely useful material. And yeah, you just start learning those machines better in the end. That's the ultimate goal there. Let's catch up on some of these questions. How you doing, Sterling? I think I saw Tom in the chat earlier too. How's everybody doing? I was interested in working for them, but everyone seems to run away these days. Apparently, all because of a few individuals. Are we talking about Daikin? Work for Daikin? Oh, here we go. Okay, I'm missing some of the chat. Let me catch up. really want to see that vertical screw. Yeah, the vertical screws are really cool. They're crazy quiet. Like they're crazy quiet. It's nuts when you're used to working on screws and then you start getting around those vertical screws. Like it's hard to understand why are you so quiet. It really is. It's wild. They work. I mean, they're a screw. They work. They've got them. They're using both a slide and variable speed with them. So it's a combination. The first stage of loading from startup is they load the slide and then they start to ramp the speed from there. They're not the only ones to do that, but again, that's what they're using with those. Uh, I like them. I think they're pretty cool. Is there a thermosiphon oil return in train machines? Thermosiphon. I haven't heard that term before. Being that you said siphon, and thermosiphon, I'm going to assume is probably you're referencing an eductor. I think is what most of the industry would refer to that as. You could correct me if it's something different. Yeah, I'm curious. That thermosiphon, I'm going to have to look that one up. Yeah, not sure about the thermo. Haven't seen them in the field though. Okay, maybe it is something different. Yeah, I'm not familiar with that. If somebody has any information, I'd be interested in hearing more. Worked on Daikin Applied. Worked at. It was a great place. Nice. You learned to do some VRF. You said you worked at, so it sounds like you don't currently work. What made you leave? Yeah, it's what made you leave Daikin. Wish Daikin, where I'm at, was half as good as. Yeah, I don't know, because, I mean, I haven't heard anything about Daikin Europe. And I think Daikin Europe is isolated from Daikin Asia. I think they're independent regions. I could be wrong with that. Um, yeah, I know Daikin North America or Daikin America. Maybe it's Daikin America. Yeah, I think it's Daikin America, not North America. Um, I've heard just a ton of positive stuff with them, for sure. RTWD and RTHD are screw machines. Yes. Yes, that's right. I was interested in working for them, but everyone seems to run away these days. Yeah, I'd be curious to know, Sterling. What are you hearing from Daikin over there uh, that has people trying to move on to something else? Just highly curious. What you've heard that might be leading to that. Don't let the chiller control the condenser water valves. It's modulating valves. Service guides, Google. Yeah. Yeah, I mean, it's just if you know how to do the keyword thing, right? That's the trick to the whole Google stuff, right? You got to figure out how to do the keywords, and whether it be using the actual models or whether it be figuring out the manual nomenclature. If you can get that stuff figured out, it's amazing how much you can find. I would advise to check them out. Leave your ego at the door. Not saying you're egotistic, but man, in the trades, you have to get your work done. Yeah. Right. The IOM is not the service guide. Right. Yeah. And there is a big difference. There's a big difference. Now you can get a lot of great information in the IOM, but it's not the same thing as the service guide. Do you think a service tech could just read manuals and be effective troubleshooting chillers remotely and in person? If you have the fundamentals. So that's a big. Okay, let's put this one up just so everybody can see it. And this is an issue that we see with some of the attempts to do tech support with inexperienced people. Okay. Do you think a service tech could just read manuals and be effective troubleshooting chillers remotely and in person? Only if you have the fundamentals of how these things work in the first place. You're going to run into a lot of roadblocks still, right? There's a lot of things that unless you've just done that thing in person and you actually intimately know that machine, you're going to really struggle being able to answer certain things or know what to look at next and how everything kind of ties in together, because one of the struggles with many of the manuals is they don't fully lay out everything, including exactly how the machine is laid out, how the whole machine functions. Like there's a lot of information that sometimes isn't covered, or it's not all covered in one manual. It's covered in multiple manuals. And to truly get a complete picture of a machine, you really have to read all the manuals, right? Or at least a large portion of them. So what I'm getting to is, if you have the fundamentals, if you have the foundations, if you understand why all these things work, why these manufacturers are using all the same principles, all the same concepts, none of them are doing, or okay, there's extremely little that any of them do that is truly unique to them. Extremely little. All right. We'll use a gas pump with Train water-cooled screws as an example. I haven't seen anybody else use that implementation. It's albeit, go for it. Yeah, there's just most everything else. Like there's multiple people using these types of methods. Multiple people. And there's a reason for that, because there's a core fundamental that makes this method make sense. And if we can learn that fundamental, then we can go from there. So that's where, like, okay, not to do a shameless plug here, but my introduction course, my certification course to chillers, right, at chilleracademy.com. Like that is what that course does. It gets you fully up to speed on the fundamentals of what these machines are, how they work, yada, 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 yada. Like that course is a complete top to bottom of that. So if you actually had all that whole course in your brain and then knew how to use the manuals and apply it, you could get pretty far. You could get pretty far. If you had a machine, I haven't worked on that machine before, but I have the manual to it. I can read it real quickly. I see how it's laid out. I see the styles of EVAPs they're using. I see the metering devices they're using. I see the style of compressors they have. I see some just real quick basics of what this machine is supposed to be. And I have all this fundamental information of, okay, this is how these things are supposed to function. When we put all this together, okay, no, I've not worked on that machine before. I've not actually put my hands on it. I've not even seen it in person. But I do know that it's doing all of this, and these things work this way. The manufacturer's not doing anything special. These things work this way from a fundamental perspective. This is just how they were engineered from the beginning. So because of that, I can now reverse engineer, okay, this is how this machine should probably be functioning. Oh, it's not doing that. Okay, well, now let's go through some steps to figure out why it's not doing that. So yeah, I think it could. I think it could. But it's not going to be easy, and you really got to know your stuff. Yeah, you really got to know your stuff. Otherwise, you're going to get lost really fast. I think York and Carrier do really good job on their IOMs. You see, now you said you work for JCI, I think, right? If I think that was you. The thing is, yes, I agree. York does a decent job. So does Carrier. But they both still have a similar fundamental issue. Whereas when you are a third party, or without going through their class. Okay, so using York as an example, if you don't go through their overhaul class and take some of these things as third party, there's a lot of information we can't get access to through JCI directly. Now, there's other means of doing this, but getting it from JCI, not so much. So, oh, you don't work for, okay, somebody made a reference to having worked for them. My bad. Either way. Yeah, I think that, especially once you know how much JCI actually has, like I've seen behind a lot of these curtains, to be frank. Now I can't really go into any of those details without getting people in trouble, but I've seen behind a lot of these curtains. And when you actually realize how much actually exists compared to how much we feel like we get, not the same. Not the same even remotely. So, but from a third party, what I like about Carrier, I don't know, that's not really a fair statement either. Yeah, I'm not here to criticize them to death, okay? I don't want to fall into that trap, and I know that I will, because I do have a lot of complaints that I would like to see from a third party perspective. I have a lot of complaints, but I don't think it's really constructive. At some point, I just gotta stop. But York and Carrier put out better information than Train does. I absolutely agree. That's the answer I'm trying to get to in my long-winded way that I have. They do a better job than Train. I agree. Really good job on their level sensor calibration. Yeah, it's true. Yeah. And that's if you can get given that there's various different types of sensors, and you got to have the right one, the right calibration process. But yes. We have a lot of time. Yeah, careful not to find the YMCA. A lot of time in the trains is giving you literature. Size, yeah. Train IOMs. Finally, you get more guides to look into with the literature numbers. Yes. Yes. Thermosiphon is what Train EU calls the oil return system, like on a RTAF. Okay. As I'm sitting here thinking about the RTAF, I guess I'd have to go back and look. I thought they were just using a version of an eductor. Maybe I'm wrong. I haven't spent as much time on the RTAF series. Like I've worked on them in the field. I've had to deal with their condenser fans and stuff. Yeah, I guess I'd have to just look, because what I have in my head, maybe it's not. The thermos are out there on the new air cooled train screws. Okay, all right. I need to go freshen up on this to make sure that I got it straight in my head. Left a contract on my own. Okay, yeah, that's a great reason. Yeah, yeah. No, going out to do your own thing, like there ain't nothing wrong with that, man. Probably works great when implemented. Wish I could do a quick read on a 300-page manual. Yeah, wouldn't we all? Yeah, even I've actually tried I've actually tried to do some experimenting with some of these AIs and seeing, okay, how good of a job can they do currently with either giving me a summary or if I have a specific question. And I've used quite a few of them. And I'm constantly experimenting with this because not only for my own like personal benefit, but if I could find a way to leverage some of these tools without having to do any customizations, right? I'm trying to find a solution where we don't have to go in and create a custom stuff, because I'm a part of some of those projects too. I've got a project I've worked on in the background that it is a custom AI tool. Now, I can't talk about it. I can't tell you anything about it, but I can just tell you that it exists, right? So there's these things that do exist, but they're highly customized, highly trained. So other than that, what are some just easy, free, or maybe even if it's not free, but just what are some easy ways that you could just throw some manuals in and try to use this technology to benefit you personally? And I've just constantly just ran into so many walls where like these AIs are great in everyday stuff, and they've learned a lot of stuff. They've had a ton of training in like coding and certain sciences and stuff, but they have not figured out commercial industrial HVAC, especially on the centrifugal refrigeration side. Like they struggle. It's rough. So anyway, something I've been trying to do my best to play with. Do you have any news on the right to repair stuff going on? I actually, yes. So right to repair in the US particularly, it's going well. There are some things that I don't know I can talk about, to be frank, that I am just in the loop on, that have been really good. It's some of the cracks I've referenced with JCI. That's part of, there's a lot more information than what I can share on that. But like some of that is coming from that, like the pressure, like there's been legal pressure I know put on them for this. I know that John Deere, who has been a huge kind of focal point to this whole issue, just got a huge clapback from the EPA, because one of the big things they were using to stand on right to repair was, well, if they gave everybody a access to their service tools, then they would tamper with the emission systems in their equipment, and it would be out of regulation. And recently they've used that argument. Recently, the EPA actually released a statement clarifying that the way that the way they're using it to defend their case is wrong, and the policy they're referencing with the EPA is wrong. So we're still TBD on some of those lawsuits and how that's going to affect them. I know that the automotive manufacturers are getting more and more pressure put on them and their softwares. I think things are moving in a very positive direction. I think the fact that without even having to go through legislation and legal battles, the fact that we have Trane with what we've discussed here with their Symbio 800 series coming in with that, and that becoming more like, is it 100% everything? No, but is it a lot more than what we had? Yes. To what I understand, given the conversation we've had in stream here today. So this is something I need to look heavily into. I really need to get up to speed on this change, but this is a positive way forward, a positive movement in the right direction. And as these companies who are more open, Daikin, while they're not an open book, they are far more open than some of these other manufacturers have been with getting access and working on their machines. Same thing with, especially Dun& Bush and using the MCS panels. as more of these, as those manufacturers become more successful, and a huge part of that success is their willingness to be service friendly to third parties specifically, it's going to continue to apply market pressure to these companies to do better. So I think from multiple angles, we have had this trend where a lot of major corporations have done a lot to hold back third-party service across the board, beyond just HVAC. And we're seeing this really, really clamp down on them. We're seeing even just throughout the technology sector as a whole, there's so many open source projects being started. I mean, heck, my laptop I use is a framework, right? I chose that laptop not because it's got all the greatest specs and not because it's the cheapest, but I can upgrade it. I can fix it. Any part that fails in that laptop, I can repair it. I just got tired of busting laptops because, well, as much as I try, I'm just not very soft with them. I try. It's not intentional. And so, like, the fact that these things are getting so much movement, to me, is a very, very solid direction as we continue to move forward, and people just not being willing to play by the proprietary rules. That's what it comes down to. People are not, we're losing our patience with playing with corporate proprietary politics. We don't want it. We're done with it. Evidence that that's working is what we've been discussing, in my opinion. Yeah, no more gas pumps. How do I find saturation temperature? Hey, you know what? There is actually an amazing app for this. So, let me put this question up real quick. All right. How do we find saturation temperature? So I'm going to use my phone here. So, not Turbo Tool, we want Ref. All right, switch over here. So if we look at the Ref tool by Danfoss, this is Danfoss's Ref tool that they have. We go into that. This is one really easy way to do that. So if you've got a gauge on a system, whether your gauge has saturation temperatures on it or not, I don't actually, man, I don't have one in here to show you. Whether they have it or not is irrelevant. What you can do is just have an app like this. Okay, this is Danfoss, so they have this is a refrigerant slider app. You can choose different refrigerants. Okay, these are my favorites I have saved. So we have 134, 123, 513, 14, yada yada yada. They have a whole list of refrigerants you can choose from. We're in 134 right now. As long as I can get the pressure, and I commend you for getting saturation, by the way. Excellent work. We can just tell it, okay, I know that my pressure is 40 psi. All right, well, that's wrong. 40 psi. At 40 psi, I know that my saturation right here is at 44 points, basically 45 degrees of saturation. And because now we can do also with this app absolute or gauge. Okay, so if you're reading in absolute pressures for any reason, especially if you're working on low pressure machines, you're going to be doing work in absolute. Okay, those read in absolute instead of gauge. So you have to factor that in, factor your elevation in, But 134 is not a pure refrigerant. It's not a blend. It doesn't have a glide to it. So if we did come to one with a glide, let's go back to favorites. Let's go to 407C. We have the ability to change our dew and bubble setting to adjust for our glide, whether we're working on the low pressure side or the high pressure side. So the dew being your high pressure side and bubble being your low pressure side in the evaporator. Oh, said that wrong. Bubble being your high pressure side, dew being your low pressure side. Yes. So if you have a glide, so this is a really, really handy app to do that. And then obviously if your gauges have a PT chart built in, so this would be a digital version of a PT chart. I don't, my actual hand copies of PTs I've got put up right now, so I don't have them here. But yeah, so to do that, you've got two saturations you're dealing with. You're dealing with your evaporator saturation and your condenser saturation. And there's lots of things we can do with that. We can find approach or temperature differences. Those would be the core primary things, especially from a chiller perspective, that we're really trying to sort out. It's also where we can get our superheat values from, discharge superheat, suction superheat. So all of that, we need saturation temperature. And that's where, like, I'll just kind of rant on this for a brief second. Pressure is not the important part. Your saturation temperature is, right? Now, obviously, we have to use pressure to get to our saturation. But once we get our saturation, almost all of our troubleshooting beyond that is going to be saturation based in terms of approach, in terms of superheat, things of that nature. Like, that's what's really determining what's going on. And I highly discourage learning troubleshooting from, okay, this is a 134A machine. I know that my evaporator pressure should be between X and Y, and my condenser pressure should be between Z and W. Like, forget all of that. No. And if you try to do that, then you've got to learn what each refrigerant's pressure range should be. Like, that's how we were brought up to troubleshoot in the early days, back before saturation was what it is today. Like, when you learn that, okay, R22 is supposed to be, when you hook up that split system, you want to be between X and Y. I don't even fucking remember anymore what the numbers are supposed to be, but like, that's how I was taught, and you did the beer can cold from there. Just forget all of that. If you learn saturation, all the machines use saturation, the same saturations. It doesn't matter whether you're working on a 123 or a 134 or a 513, a 514, I don't care. The saturation temperature that we're using is the same temperature across the board. If we have a flooded evaporator where we want a 45 degree leaving water temperature, we know that our saturation at full load should be no more than 3 degrees, which means we should have about a 42 degree saturation on that evaporator at full load, which would mean we have a 55 degree entering water for most machines. Right? If we can get that whole concept down in our brain, and I don't care what the refrigerant is at that point. Once you get the pressure, you get your saturation, now you have the information you need to troubleshoot everything else. And you're not having to learn the nuances of every freaking refrigerant and yada, yada, yada. So good on you for even asking the question. I appreciate it. Keep going. And saturation is everything. Everything. Saturation is everything. I'm going to just continue pounding that home every day. See, because they collect the oil and push it back up to the compressor using hot gas injection, thermosiphon. They collect. Oh, is that what they're calling another name for the gas pump? It's a braze plate with a sludge line. I see your question, the service question. Give me just a second. So is thermosiphon the is thermosiphon supposed to be like the fancy way of calling a gas pump? Like the, I guess, less proprietary way? Or is it the proprietary way of saying that? At that point, I really need to pay attention to the RTAF more. Because if they're using, I could have swore they had a eductor assembly, but maybe I'm wrong and it was a gas pump assembly. Man, that would be stupid. Put the gas pump on an RTAF. We'll come back to that. Somebody tell me. Is thermosiphon a code for gas pump? All right, question here. Once replaced gasket. Yeah, I know that they they changed they modified it. So instead of having four lines, they reduced it to a 3-line system on the gas pump. So all the newer ones are using a 3-line. They eliminated the 4th, which was the vapor vent line going back to the top of the evaporator. That got deleted to where now it's just those single drain, and then you had the hot gas line, and then you had the return back to the compressor, and they just deleted the 4th line. Man, I've got to go pull my books. I'm gonna read into this oil cycle on the RTAF. That is so disappointing that they put that on that machine. So, okay, I need to stop. All right, once replaced a gasket on the suction side of a barrel after the repair and a deep vacuum, we changed it back to spec, charged it, inspected, was all good, working shape. However, the dreaded call, oil leaking, IYO, what, in your opinion, what do you think could have prevented this? Oil leaking from what I think was the discharge side of the compressor. Replace the gasket on the suction side of the barrel. But you said you're oil leaking from the discharge side of the compressor. Well, I guess, okay, let me get this whole question in, and then we can talk about it. It's going to take me a second to fit all this in here. And then just give me 1 second. We'll get it all in here. I've been trying to figure out a better way to do this, but alas, I have not found one. Okay. I once replaced a gasket on the suction side of barrel chiller. After the repair and a deep vacuum, we charged it back to spec, inspected, and all was in good working shape. Okay, so you inspected, so you didn't have any leaks, anything like that. However, the dreaded call, oil leaking from what I think was the discharge side of the compressor. In your opinion, what do you think could have prevented this? Sorry for the winded question. Yeah, no, there's nothing wrong with the question. The question's great. The only thing I would ask for is maybe a little more information. Do we have a particular chiller model number we're discussing? That would help kind of indicate some possible things. So if we had a model, what particular model were you working on? That would be great. And when you say you inspected, I'm assuming you did a leak search. Obviously, you're able to pull a successful vacuum. And hopefully you did a standing vacuum test. Okay, so there's some follow-up questions I have. Did you do a standing test on the evacuation? So let it pull down, and depending on the machine, at least 2 hours, 4 hours. I mean, this sounds like a screw. So it sounds like you're working on maybe a water-cooled screw. Maybe it was an air-cooled. This wouldn't be a centrifugal, being that you're having oil in the discharge like that. And you wouldn't have flanges like that on a scroll. So the only thing that leaves is a screw compressor. So yeah, did you do a standing? What kind of standing vacuum did you do? Did you make sure it held? And I know there's a lot of training out there that says, oh, you only need, if it holds for 20 minutes, 30 minutes, or if the micron gauge shows a proper trend. So like we have these, what they call them, blue vac gauges. They give you like a leak report, and as long as it's below X value, it's considered good. I don't agree with any of that personally. Not for this scale. That may be fine for smaller systems, smaller tonnages. I don't agree with that for these large machines, large systems. They need a lot more time, and the risk of not giving it the correct time risks a lot of refrigerant, risks a lot of oil. Like there's the cost of the mistake becomes far greater. So that's where, like, how much time did you give the vacuum? If you gave it less than 2 hours, I would say maybe you would have seen that if you gave it more time. Because here's the thing, when the machine is running, when the machine is under a positive pressure, it could have held. When you put it into a vacuum, it may have started leaking. And then once it started leaking, you put it back under positive pressure and it continues leaking. Like that happens all the time. So I would highly, like, things like that are what we're trying to catch. You can do the world's most perfect leak search, and the moment you put it under an evacuation, something lets loose and it doesn't go back. Let's see. It could be that we started leaking on the discharge side after doing a suction side repair. I mean, that would be the main thing I'm actually suspicious of. If you weren't having that discharge side repair prior to if you weren't having that discharge side leak prior to the repair, I'm thinking evacuation is the most likely cause. Otherwise, something else happened in the process. Either after you finished, it was already on the edge, something happened. And it's possible that it may not have been immediate. So you may not have seen it leaking right at startup, but after some time, after it got hot, after just enough vibration, if the machine was previously undercharged and now, like, that was part of your repair, was addressing a leak to then fix the charge, that again, that changes things. So the machine may not have been able to load up for a long time, and now you've got it to where it can load up again. And because it's loading up, it's also running hotter discharge temps. Like there's a lot of things that come with that. And because of that extra vibration, because of that extra temperature and just mass flow through the discharge line, like your total CFM through the compressor increases because you've got a good charge now. Now a weak point that was already existing just couldn't hold up anymore. Like those are highly likely scenarios. Now, are you going to convince the customer that it's not your responsibility? Probably not. But in terms of just understanding why it happened in the first place, like that's where I would go with some of that. Yeah, if you have any additional feedback, would be helpful. I'll let this sit here for a second and give you some time, if you can, there, sir. Apparently, Train have implemented an AI model on their internet, supposedly for the sales team and even service team to use. Could be a ChatGPT optimized for HVAC. Yeah, I mean, like I said, I've seen these models. They do exist. They do work. Like when they're trained, which is not an easy task, when they're trained, they do work. So I do think that not only from like the internal side on the manufacturers, but long term, I think we are going to start to see some of these things come out. They're far from perfect right now. How much that'll improve, I don't know. That's what we're trying to work on. Pressure converted to temp equals, yeah. So Sterling, y'all are going to get me. See, today is the day of rants, isn't it? So I've got another rant I could go on with the whole AI and replacing. And I can't tell you how many people I've had to debate this with. High level. I'll just give you the high level, my high level opinion, if that's even possible. Oh, we'll come back to that, Sterling. This is an extremely, yeah. Yes, you had the oil question. So what, in terms of the, yeah, so the main question right now is, like, do we have a machine model number, right? Do we have the, like, how long did you leave the vacuum standing for, right? So model number, how long was the vacuum standing before you charged the refrigerant and called it good? How much rise did that have? Because those could have been things that might have indicated a leak. Yeah, always up to, yeah. Yeah, those are the core questions right now. I'm assuming, based off of the name, is your name Jesus? I'm assuming. If that's wrong, I'm sorry. I have very limited information on what people's actual names are, so I just have whatever the tag says. Anyway, like I said, I'm going to let this question stand for a second because I do want to follow up on it. Like, if we can get some more information, we could continue going deeper. I'm happy to do that. Now, in terms of the AI, so ultimately, and I know Musk is touting his Optimus robots and stuff right now and all the AI and AI. The fact is, what we are doing is, in my opinion, requires extremely advanced motor movements and understanding what it is we're working on. Like, I don't think robots and the AI is going to I don't think they're going to advance, especially in our lifetime. I don't think they're going to advance far enough and become cost effective enough to challenge us as technicians. Now, is it likely that these things will make technicians, especially those who lack training, more capable and better at resolving whatever they're working on? Yes. I've already seen that. I think that is already happening. That's not replacing a technician, but that is giving a technician another tool, like all the other freaking tools we have. I mean, use Bluetooth gauges as an example. I literally switched to Bluetooth gauges because I got tired of trying to run around the unit to take all my measurements. And I could just hook it all up and stand in one spot and get a freaking reading. That's why I switched, okay? And we've had, like, these apps that do this have had their own analysis stuff for quite some time. That's not necessarily AI. I think AI is going to continue serving that type of a role. It's just going to be another thing in our tool bag that we use to just do a better job, do it faster, do it more accurately, have less misdiagnosis. You want a second opinion? Okay, take some pictures, throw it into your system, have it just give you some feedback. If you don't know where to start, again, take some pictures, throw it into the system. Have it just kind of give you an idea on where the heck do I even start here, because I'm not really sure right now. And then just start. But what it's not doing is fundamentally replacing you, your critical thinking, your ability to understand this machine and troubleshoot through it. And like these AIs, I've done this. Like I've given them the correct information. I've given them the books, and they like even they are not doing a good job interpreting this stuff. And maybe this is a temporary issue, but just we haven't even got close. I mean, close to the AIs being smart enough to understand the equipment we're working on without us filtering it for them. I know this because I'm actively working on these things. Much less the idea that this is then going to get put into a robot that is going to be able to go in and do the work that we're doing. I know. So here's something we have to be careful with. These AI people and companies, and like, who, just pick one. I don't care who, the robotics and the AI companies. These are publicly traded companies, most of them. They benefit from all of this positive market, all of these upside trends. They want people to invest. The only way they can do that is to spin a public narrative that they're on the edge of the next revolution. Reality is, they're not. They're not. And if you really, really pay really close attention to what they're saying when they do talk about it, not in short snippets, but in some of these long form conversations that they have, you really start to realize how much they aren't there. They want to be, they're trying to be, and they're trying to keep public opinion on their side. But the fact is, they're not there. They're getting closer. So I don't think we're gonna see this in our lifetime. I really don't. Maybe I mean, well, what's going to happen 50, 60 years from now? Who knows? But we're a long ways away from it starting to replace us. Now, is it going to affect other markets? Sure. Just not us. Yeah, just not us. And see what are you stirring up down here, Sterling? Always got something. I know. They might replace management with a bloody robot, though, which in some cases wouldn't be. I mean, human relationships are not that cut and dry, you know. I don't know about management getting replaced. Management having a tool to help work through issues, maybe. I could see that. And I'm the one teaching them. I mean, to a degree, I can admit to that. I am actively a part of some things happening that are in this sector. Okay, that's all I can say. Just saying. Yeah, you can hang me on the stake, if you will. I'm down for it. I see Miss Lioness has entered the chat. Miss Schamberger herself, the HVAC time lady, who keeps everything in motion in the background. If it wasn't for her, very little of what I would have would exist today. So let's all give her a round of applause, everybody. I want to see the heart start firing off. We got the lady in the chat here. Yeah, exactly. See, if I'm on its side and I teach it, maybe I'll be spared. That's kind of the high level thought, right? I'll be amongst the ones that it pets and feeds more routinely than the rest of us. Oh, you guys are nuts. Let's see. Still uses. Let me catch up on where we're at here. Yeah, Jesus. If you got any extra info, man, I'd love to hear it. It would help us be more specific with what we're trying to talk about. Let's see, if memory serves, they warm up the oil through the brace plate heat exchanger, then they inject hot gas to push it back up to the compressor and supposedly evaporate any remaining liquid refrigerant within the oil. Yeah, I mean, I'll look into this. I'm gonna dive into this, to the thermosiphon process, and maybe we do like a fun fact time with the next stream or something. That may be a fun follow up. Extremely municipal in oil. Stay competitive. Well, that's the thing. So the RTAF was the successor to the RTAE, which fell absolutely flat on its face. Like, the RTAE, from what I've seen and understand, like, it was a complete disaster for Trane, and they tried to fix it and then pivoted and modified it to fit the RTAF that we see today. So yeah, everybody I talked to, nobody really, I don't think I've talked to somebody who actually thinks the RTAF has been a successful line, but they've actually sold quite a few of them, just saying. We'll see what happens. I don't think they're going anywhere, personally. They may come up with a new revision and they'll just continue iterating on it and fixing it. Is what I think they'll do long term. So it'll eventually become a good machine, more than likely. All right, carrier 19XR active Delta T and surge line Delta T. Tell me. Yeah, so on that 19XR, I'd like some more information, but it sounds like you're probably running a high lift. Maybe your condenser side is running a high split. I would need some more information to give you an accurate direction there, bud. Oh, I make it work too much, yeah. Honestly, as frustrated as I get with AI, it probably will just come after me for vengeance one day. It's probably just I'm gonna tell it to F off one too many times, and I'll just disappear into the void of the matrix. Okay, we still got some time. I want to grab another question here. We got that one done. We can do this one. Oh, nope, you go back. We can do this one quickly. Okay, so does the RTAD 145, so the 145 ton machine, work with TechView? So the AD is a earlier version of the HD that we have today. They came out, or at least the ones I'm familiar with, had the UPC2 control panel. Okay, so let's talk about this over here. Trane has had the UPC1. That's not a U. UPC2. Then they went to the CH530 panel. Then they went to the UC800. Now we know that they have a Symbio 800 series. Okay. That being said, this one was the old school, had like the blue. Here, let's just pull some of these up through the old schmoogle real fast, just so you can see. Come on, just me and technology, we're gonna fight. All right, let's go train UPC1. That's not a 1. Let's go to images. Let's just show you. Okay, so you can see it there. Is there a better? Nope, not a better image. So this would be an example of a UPC1 panel back in the day. Okay, little blue display, very, very simple. Wasn't a whole lot to it. Honestly, I don't even know how many people today have even seen that panel in the field. It's I don't know. Now, those could be upgraded to a UPC2 line, which is this. So when you see this particular touch interface, or I say touch, it's not touch. When you see this interface on the front, this is a UPC2. That is what I've seen with the RTAD series, is a UPC2. The short answer is no, TechView does not work with UPC2. Okay, these two were fully independent, so this would be a no and no. Okay, no TechView. Now the CH530, which is the DynaView line, and my example is put up in storage at the moment. So we're gonna go with the CH530. Okay, that's where we get into the little green touchpad. Okay, that's the 530. This uses TechView. Okay, so TV, TechView. This is still free to get from Train. You can get access to it. Great tool. I absolutely love this line, by the way. Like, I thought these touchpad controllers weren't the greatest. They had issues with wearing out with age, but like they worked. They worked well. And TechView TV was a great little software. Really, really easy to use. There's still a lot of machines that run this software to this day. A lot of machines. So if you're trying to use TechView, this is the only control package it's going to work on. It does not work on a UPC2, which is what the RTHD originally shipped with. Now, or at least the ones I've seen have the UPC2 panel. I don't know if they ship with the UPC1 or not. To be frank, I don't know, but I know that I've seen them with these. Now, I'm fairly confident they have a CH530 upgrade package. So I've done upgrades from 1 to 2. I think there's an upgrade to take UPC2 to CH530, but it's a complete panel. Like, from here to here is a big difference. These were still wired sensors. This is all a communication comm bus. Okay, so everything's linked together over a data bus. So it's radically a complete change. I haven't seen any of the RTAD having that upgrade. I'm just saying that it wouldn't surprise me if there was a possibility to do that. Just saying. And then with the UC800, and then I believe the Symbio 800, this is where we get into the TU software, where you have to get a license from Train and all this stuff. So just to kind of lay that out, your answer would be just no. Unless it's been upgraded to the CH530 panel, no, it's not going to work. All right, quick question. What's your preferred method to get line temp, laser, K-type clamps? To get temp. I definitely don't like laser. Here, let me read through it. I've had issues with all of them. Sometimes each one gives you a different reading, even though I prep the copper by cleaning it. I apply electrical tape on the K-type to stick it. Yeah. When you're trying to get a subcool reading and you get a 4-degree difference between two different thermometers, yeah, it just drives you mad. Over here, the C is a retrofit arm and a leg. Yeah, so K-type okay, the short answer is clamps, which depending on the clamp, most of the clamps are a style of K-type thermocouple to begin with, right? A lot of them. Now, that's not true when you get into the Bluetooth. So some of these Bluetooths are actually using thermistors, right? And I like those better. So specifically, clamps with thermistors is what I would prefer above all else. My backup would be K-type. And I do not like the laser. I do think like the laser and thermal imagers, stuff like that, which they're completely different. I know that. I'm just saying, in those categories, they can be useful for quick reference numbers. But if we're actually trying to get diagnostic data, not just okay, what is my ballpark here? I will not accept laser, like the temp guns is what we're referencing there, right? The temp guns or a thermal imager data, stuff like that. I am not taking that as valid diagnostic data. Personally, that's just my opinion. And I would much prefer a clamp with a thermistor, not a thermocouple, which is what most of your K-types are going to be, a thermocouple style. So, yeah, that's the short answer to that. I want clamps. And that's one thing. That's one of the big things that drew me to the Testo clamps in the beginning. When I switched to Bluetooth, was they actually have a thermistor, and that thermistor was removable, so you could actually pull it out and just tape it to the line when I needed to. But I'm still getting a thermistor temperature reported back to me via Bluetooth. So that's why I latched on to those so much. And I still love those for that reason, because it doesn't really matter what size of pipe I'm trying to attach it to at that point. I can just pull the sensor straight out of its little insert from the clamp and just tape it to whatever the heck I need to. And I know I've got a reading that I feel very, very confident with. Makes it easy to test the sensor later as well. So, yeah. I like it. I like it a lot. Okay. Any other questions? Any other questions? It's good to see everybody. Really appreciate your time. Reminder, I have my in-person service classes coming up. If you're wanting to get enrolled in those spring classes, you got to get into it. Got to get into it quickly. I do have some flyers I made for those. More specifically, the Miss Lioness there made for me. So if you want to get some of those flyers for additional information, again, just send me an email. It's hvactime@hvactimetx.com, and I can share that with you. Same thing with the certification course. I'm spending a lot of time making improvements on it. We've made a lot of progress on it, and really excited with how it's coming along and some of the recent improvements that we've been able to make. So, yeah, I would heavily encourage you, like that course, like my whole methodology behind the way that I see to teach this is I don't want to teach you each specific model. I'd rather teach you how all the machines are using their various components, because they all use the same components in similar ways. That additional question, go ahead and get it in. We'll see what it is. Just go ahead and submit it, please. So if I can teach you how the basic machine works from top to bottom, then at that point, you don't have to know every single in and out on each model and have all that stored in your brain. You know that, okay, a flooded evaporator works like this, period. York's flooded evaporator compared to Train's flooded evaporator compared to Carrier's flooded evaporator compared to Daikin's flooded evaporator aren't different evaporators. They're the same freaking thing. They have the same limitations. Okay? So that's my point. That's exactly how I'm approaching all of this, not only from the hands-on class, but also my certification courses. I'm teaching you those fundamentals so that it doesn't matter what you walk up to. You can look at it, you immediately know, okay, because my pipe connects here and here, this is this style of heat exchanger. I know how this is supposed to function now. I know what to expect from that system. Even if I've never touched this machine a day in my life, at that point, the hard part is just figuring out how to work the control panel, not, which even those have a lot of very similar threads to them, but it's not trying to understand what the machine is doing. It's just understanding how to navigate the controls and get the information you need, right? And that's, I bet, it's a much stronger place of approaching a troubleshoot scenario when you can come at it from that angle versus I'm having to learn this entire machine because I haven't worked on this one before. It doesn't matter, okay? The fundamental principles stay the same. All right, so the question we have here, can you go over the method for pulling gas on air-cooled chillers? Do you even use the push-pull method, or do you just recover normally with pumps on? I could get into a much more detailed conversation with that. What I am going to do, I'm going to save this real quick because I think it's worth having that more detailed conversation. But we're also I'm just going to give you a quick high level here. So on most of your air-cooleds, if it's not at a flooded evaporator, which majority of them aren't, almost all of them are going to be either DX or braze plate style evaporator. So DX shell and tube or a braze plate. No, you're not going to do a push-pull with that. It's not going to work. It's just a waste of time. You're going to have to suffer through doing a standard recovery. That's all you got. The only time push-pull is going to push-pull or pull-pull. So you said pull-pull. I will correct myself. Either method you want to go with, push-pull or pull-pull, requires access to the liquid refrigerant in a concentrated place. And if you do not have that, it's not worth your time. It's just going to waste time. So at that point, just go straight to a standard recovery. You'll be able to use those methods on larger machines that are using falling film and flooded evaporators. Then you'll do great. You can do that all day long. But if you're in your standard air-cooleds, that's not going to be an option. So some exceptions will be some of the carrier air-cooleds. The Train RTAF does have a flooded evaporator. The Carrier 30XV series and the 30GX series use flooded evaporators. The York YVAA and the YVWA use a flooded evaporator, or a falling film more specifically. The RTAC has a falling film. Don't listen to Sterling, please. Has a falling film evaporator. So that one you can use a pull for. Let's see. There's probably other examples. See, some of the Dunham Bushes use flooded evaporators. So there's just identify if your evaporator is flooded or not. If you want a really quick way to determine that, so you have a shell and tube heat exchanger, and you want to know, is this flooded or not? Is the refrigerant, is the water connecting to the side, the long side of the shell, or is it connecting on the end, where the end bell is? Okay, if it connects on the end bell, you're flooded. If it connects on the side, you're a DX. Yeah, CGAM, brace plate, yeah, liquid ported bottom. I could use pull on this. Just one hose. Yeah, so with it pumped down, pulling from I would say try it. If you don't know, try it. My experience, you'll get some liquid, right? So it's not that you're going to get no liquid, but you will get some liquid out, but you're not going to get the bulk of the liquid. You're only going to get a portion of it, even with it pumped down. So, but what I would encourage is try. Just see what happens. See how much charge you can get out and weigh that. And then once you're no longer getting that liquid out, switch over to the standard and see how much more you get out. Vapor by itself doesn't take that much weight. Um, the Yeah, the vapor doesn't take that much weight. So if you end up switching to the vapor and you still get as much, if not more, as you got with the liquid, then you still had a tremendous amount of liquid trapped in the system. Okay. The vapor on that small of a machine should only be a few pounds, maybe 5 or 10 pounds, something like that, if the whole circuit's just vapor only. But and just to clarify, don't pull cores to just let it dump into the atmosphere, but pull cores and just do the recovery, right? Just do a standard recovery. But again, experiment, play, have fun, try it. If it doesn't work, you tried it and you know for next time. Would I personally try it? No, I wouldn't even bother. On a job like that, I would go straight to a standard recovery, call it done. Yeah. Anyway, MTT. Make the time for your family, for your spouse, for your kids. We have to make the time. It's not going to be there. Take care of yourself. You'll be careful as we gear up for summer. It's coming faster than we think. I'll see y'all later.